wanna play a game?
Sure, what you got, man?
Okay, let's play a little game, man. We got 2 piles with each an equivalent number of dominoes, okay? To play by taking as many as you want from one pile. And then I go and I do the same thing, okay? You ready?
How do you win?
To win by taking the last feature from the board, okay? Do you wanna?
Sounds easy to me, Tony.
Okay, man. Do you wanna go first?
Oh, of course. I'll start off with 3 dominoes.
Okay, that's okay, man. Go ahead.
They're ready for this time.
That's no problem, man. Go ahead. It's your turn. And I win, man. Look at that.
No. No way, man.
Nah, man, it's no man.
Let's play one more time, but this time we play with my rules.
Okay, that's no problem, man.
I set the number of pieces we put down.
That's no problem, man. You can put as many as you want, I will always win.
Hey, we start with 10 last time, I want 4 more. 14.
Está bien, man. Está bien.
Hey, but I go first again.
Go right ahead, man.
I'll take away 5 this time. You know, I know what I did wrong last time. I was switching up the numbers. I'm gonna go 5 again.
Okay, man. That's no problem.
Oh.
I win, man.
Nah, it's impossible. You're cheating, Tony, I'm telling you.
No, man. Listen closely, okay? In this world, you got 2 things. The basic step and the inductive step. And you don't break that for nobody, okay, man? Now to explain a little better, say hello to my little friend.
Hey, what's up? So let's go over his fatal mistake, which was choosing to go first. Because using strong induction, I can prove that in this game, the second person can always win. Here's an example of regular or mathematical induction, which says that we assume P of k true for some k. We use that to prove P of k plus 1, therefore proving the statement true. Now, strong induction is different because we assume P of 1 and P of 2 and P of 3 all the way up to P of k true, and we use that to prove that P of k plus 1 is true, therefore proving the statement true. So the base step is the same. We look at P of 1. When there's 1 domino in each pile, if the first person removes that 1 domino, which he will have to, then the second person just removes their 1 domino and they will win. So we know P of 1 is true. So for the inductive step, we have to look at P of j is true for j, which is greater than or equal to 2 and less than or equal to k, and j is the number of dominoes in each pile. So for P of k plus 1, there are 2 things that can happen. The first thing that happens is the first player removes all the dominoes from his pile. This will obviously mean that the second player will win because all the second player has to do is remove all of his dominoes from the pile and he will win. Now, if the first player does not remove all their dominoes, all the second player has to do to win is just keep on matching the number of dominoes that the first player removes. We can prove this true because let's say that the number of dominoes the first player removes is r. And let's make r greater than or equal to 1 and less than or equal to k. This means that if we keep on matching this, the number of dominoes in each pile, which will be equivalent, will be k plus 1 minus r. And based on the value of k and based on the value of r, we know that k plus 1 minus r will be between 1 and k. This means that P of k plus 1 is true, because P of k plus 1 minus r will be true, since we know P of 1 is true, and all values from 2 to k is true. So P of k plus 1 minus r is true, so P of k plus 1 is true, because from every P of k plus 1, we can reach P of k plus 1 minus r just by removing the same amount of dominoes from each pile. Therefore, we have proved P of k plus 1, proving the statement true.
Inductive reasoning is one of the core elements of mathematics. Kind of like working out your core in the gym. What's up, nerds? I'm bro number 1.
And I'm bro number 2. And today, we're gonna teach you a thing or two about inductive reasoning.
Or what I like to call broductive reasoning.
Let's hit it.
When you're working out, you gotta do a warm-up set. You can't just walk into the gym and expect to bench 315. Unless you're me, which you're not. Let me show you how it's done. You simply grab the bar, you hit a rep. Then you hit another rep. And another rep. 999, 1,000. Mathematical induction works similarly to working out. There's levels to it. In working out, we call it the warm-up step. In mathematical induction, we call it the number 2. What do we call this? Basic step. Before we move on, let's do a quick set of legs. Let's go do biceps. We just went over the first step, which is the basic step, which is showing you the first instance of the problem is true. Now we're going to go over the second step, which is the inductive step. And to help me show you that, we have some dumbbells in front of me. So let me explain. The first step is showing the first instance is true. In this case, showing you that I can do 1 rep. Now on the inductive step, we're going to show that for every K rep I can do a K plus 1 rep. And another one. And another one. Yo, bro number 2, what does that mean? Superset! Also, don't forget to rest. Nugget. Sometimes you'll be at the gym and you'll find yourself doing some cardio. And then you realize you're doing something completely useless. So you switch to dips. We're gonna do a pyramid workout, which means for the first set, we do 1 rep. For the second set, we do 2 reps. And the third set, we do 3 reps. And we do this over and over for more sets.
Hold on a second, bro. How many dips are we doing in total?
We got 1, and then we got 2. Damn, I don't know. I was never good at geometry, man.
Hold on. Isn't this that whole n times n plus 1 over 2 thing?
I don't know. Why don't we ask our protologist?
What's up? I'm brotologist Eli.
And I'm brotologist Foster. And today I'm going to be showing you our proposition P of n, that the summation of the first n natural numbers is equal to n times n plus 1 over 2. So first, we need a base case. So we have the summation from k equals 1 to 1 of n, and clearly that's 1. We plug n into our formula, 1 times 2 over 2 gives us 1. So our base case works. So now our next step is the inductive hypothesis. And we want to show that P of n implies P of n plus 1. So we have the summation from k equals 1 to n plus 1 of k. And that is equal to summation of k equals 1 to n plus the last term, which is n plus 1. So using our hypothesis, we plug in n times n plus 1 over 2 and then add n plus 1. And we find that this is all equal to n plus 1 times n plus 2 all over 2. And that is just equal to P of n plus 1, proving our inductive hypothesis. Therefore, the sum of the first n natural numbers is equal to n times n plus 1 over 2.
Inductive reasoning is one of the most crucial concepts of mathematics. Almost as crucial as scrolling through your Instagram when you're at the gym. Or wearing a tank top when you're working out. Or being completely shirtless. Because if you can't see your palm, then what's the point of even working out? Please subscribe to our channel. New videos. Yo, brotologist, when do we make new videos?
Every extra credit opportunity.